Hello, beautiful people. I'm going to go ahead and go over notes 3, which is going to cover handout 4. I do want to apologize for the lateness of the video. I was here at home with my son and my daughter, and it's just been a lot. So this is the only time I got the chance to record. So we're going to do this warm up. We're just going to show 2 different ways that we can calculate the amount saved at week 50. I'm just going to go ahead and skip the second way. I just want us to kind of just jump into this and not take too long. So first things we need to do is we need to set up the equation, but we need to find the slope first. So this is x, this is y, and if you hear the baby crying, again, I'm so sorry. So here the x values are adding by 1. And here we're adding by 70. Okay. And you just need to find the slope from 2 points. You don't have to do the entire table. Just take the slope from 2 points and that will be it. And then remember, the slope is going to be the change in y over the change in x. So how is the y changing? It's changing by 70 and the x is changing by 1. So our slope will just be 70. Okay. Now, the next thing is like, okay, well, what's going to be our y-intercept? So if we're starting at the first term, we need to go backwards to 0. And so that means we're going to subtract 70. So 90 minus 70 is going to be 20. So at week 0, there's $20 saved. At week 1, there's $90 saved. And so our slope is telling us that there's $70 being saved per week. Okay. So let's go ahead and set that up. So we're going to have, let's just do it in the explicit form. So f of x is equal to our slope times x plus the initial value of 20, or the y-intercept. So we want to know at week 50. So weeks represent the x value. So we're going to plug in 50 for x. Okay. 70 times 50 is going to give us 3,500 plus 20. So $3,520 is being saved. Okay, so that's how much we would have there. Okay, so first objective, I can graph lines in point slope form. So point slope form, we have y minus y1 is equal to m times x minus x1. x1 and y1 are just points. So any random point that is on the graph, that is on that line. Okay, so we've done some examples of those where I said, oh, graph this line. It was in the Algebra 1 review. But we have other two different ways that we could write this. We can rewrite it as y is equal to, if we were to add the y1 to the other side, we would have m times x minus x1 written out the complete same. We're just moving this to the end. And we added it to the other side. So that's another way to write it. Or you can add it to like the front. So y is equal to y1 plus m times x minus x1. Point slope form can be written any of these 3 ways. I'll tell you right now, I will try and stick to this way right here. Okay, adding the y-intercept or the y value at the end. Okay, and again, the m is going to be the slope, just like in slope-intercept form. So we're going to go ahead and graph y equals negative 1/2 times x minus 3 plus 5. So let's go ahead and label what we have. We have a slope. Our slope is going to be negative 1/2. And we're going to label the x1 and the y1. So that is going to be the point that we graph, and then we'll use the slope. So this will be x1 and this is y1. And make sure you take the sign that's in front. So our x value is going to be negative 3 and our y value is going to be positive 5. Okay, so negative 3 is over to the left and then up 5. And we have a slope of negative 1/2. So we're going to go down 1 over 2. We're going to go all the way across until we can't anymore. And then once we go all the way across, we're going to go back to the very first point we crossed and plot it. And we're going to do it in the other direction as well. Okay. And always, always, always we need to draw a straight line through our points. So use like a notebook, piece of paper, book, something, a ruler, whatever you have. You can make anything with a straight edge. Okay. And I know that's not that straight, but that's pretty much it. Okay. Example 2, y equals 4 plus 2/5 times x plus 1. So first things first, let's plot this. Let's write down our slope, which is 2/5. So we're going to rise 2, run 5. And let's go ahead and label our x1 and our y1. So the x1 will always be with the x inside the parentheses, and the y will always be outside, right? That's the y1. And again, you can see in the example 1, it was written one way. Then example 2, the points of form is written the second way, and then the checkpoint is written the third way. So just seeing that you can see it's all the same thing. So our x1, y1, our values are going to be oh my gosh, I completely okay. Apologies. Go back to example 1. So you see how it has the -3 right here? Okay, that means we take the opposite sign. It's going to be +3. So I was like, I know my graph looked a little weird. So it's always going to have the minus right there. So your x1 and y1 is actually positive because it's subtracting. Now, if you see a plus sign, that means it's going to be your points are negative because a negative plus a negative is if you have a negative times a negative, it's going to be a positive. So I know I kind of messed that up, but if you see x minus x1, it's going to be positive. So this is actually +3, +5. And then this one here, and we'll go back and I'll regraph that. This one here is, we see the plus sign, so it's going to be a -1, and that y is just +4. Okay, so let me go back and regraph the other one. So it's +3, 5. Again, I'm so sorry. I'm super scatterbrained today. We're going to go down 1/2 and just replot that. And again, in both directions until you can't anymore. And I'll just go ahead and try and sketch that line as best as I can to save us some time. Okay, now -1, 4. Slope is 2/5, so up 2 and over 5. 1, 2, 3, 4, 5. Down 2, 1, 2, 3, 4, 5. All right, that's as far as we can get. Only 4 points. Okay, I want you guys to go ahead and do the checkpoint, okay? And again, if you see that it's negative right there, that should be a positive point, and here it's a plus, so you should have negative. So I'll just go ahead and hint that for you already. You need to identify the slope and then graph. So our point is going to be, this is our x1, this is our y1, so that is a 5 and then -2. Now, if you're wondering, well, how come that one's -2 and the other two weren't? Well, look at where the y1 is at. It's on that left side, like the very first one right here. Okay. And so since it's like that, then you take the opposite sign. If it's on the right side with everything else, then it's just the sign that's in front of it. Okay. So do the slope and go ahead and graph that one, and I'll be checking that in class. Okay. Just have to make sure this computer is charging before it dies on me. Okay. Lesson objective number 2, I can write an equation of a graph in point slope form when the y-intercept isn't obvious. Okay. So first things first, we need to identify, okay, is the y-intercept obvious? That means, can you clearly see where it crosses the y-axis, like at a perfect point? Well, if we look here, our line here, right, it does not cross at a perfect point. So is the y-intercept obvious? No. So in this case, this is when you would want to use point slope form. Okay. So first off, let's pick a point. I'm just going to use this one right here. And that's going to be 1, -3. Now we have to find the slope. Okay, and if you hear the baby and my husband in the background, They're here now in the room. We're going to do from that original point, we're going to go rise and run to get to the second point. So we're going to go up 2 and we're going to run 3. 1, 2, 3. So the slope is going to be 2 over 3. Now we just need to write it in the form of point slope form. Again, I'm going to just write it always in that second one, the one I highlighted at the top. So we're going to have y is equal to our slope times x minus our x value plus our y value. And I can actually just write that as minus 3. Okay, but just for your thoughts, I will leave it just like that. Okay, so is this y-intercept obvious? Yes, it is, right? It crosses clearly at 4. So I would just do this one. If we weren't practicing point slope form, I would just do this one in y equals mx plus b, which is slope intercept. So let's just go ahead and get a point. I'm going to use that point right there. That's going to be 5, 1. And then our slope, automatically you can see that this line is decreasing from left to right. So we know our slope is going to be negative. So we're going to go down 1, 2, 3. And to the right, 1, 2, 3, 4, 5. So our slope is going to be negative 3 over 5. And let's go ahead and write that out. Y is equal to negative 3 over 5 times x minus 5 plus 1, because it was a positive y value. All right, I want you guys to go ahead and do this one here. Okay. All right, lesson objective number 3. I can write the equation of a line and point slope form that satisfies a set of conditions. So we're going to be talking about parallel, passing through, perpendicular, all those things here. So if a line is going to pass through that, that's basically we need to find the slope and then write it in point slope form. So let's go ahead and label our points. This will be x1, y1, x2, y2. We have to do the slope formula. So m is equal to y2 minus y1 over x2 minus x1. So make sure you plug them in where they go. That is why I always label, because to this day I will still mess up. So we have 1 minus 4 over negative 2 minus 5. So we have 1 minus 4, which is negative 3, and negative 2 minus 5, which is negative 7. A negative divided by a negative is going to be positive. So our slope is 3 over 7. It's not negative 3 over negative 7. It's positive because we have 2 negatives there. All right. So let's use our x1 and y1 for our equation. So y is equal to 3/7 times x minus 5 plus 4. All right, when something is parallel, okay, parallel, you need to know this. This means they're going to have the same slope, okay, same slope. Parallel, same slope. That, remember, parallel lines look like this. They never, ever, ever cross. Okay, they're going to have different y-intercepts, whatever they pass through, but if they have the same slope, they're automatically going to be parallel. Okay, so our slope of this line was 1/3. So I know my m is going to equal 1 over 3. And my point, it wants it to pass through 2, 3. So my point that I'm going to write my equation with is 2, 3. So y is equal to 1 over 3 times x minus 2 plus 3. And I will graph these after I get all the equations written down. Okay. Or you know what? No, you'll graph them. I want you guys to graph all the equations. Okay. All right. Looking at the third one, we want something that passes through negative 4, 5 and is perpendicular to y equals negative 3 over 4 x plus 2. This right here, that means perpendicular. So perpendicular is where those lines make that perfect cross like that. Okay. Perpendicular lines are going to be flipped and it's going to be the opposite sign. So if our slope is normally, this is the original slope. Let's say this is M, okay? A perpendicular slope is going to be the reciprocal, so 1 over M, and the opposite sign. So if it was a negative slope, it's going to be positive. If it's a positive slope, it's going to be negative. And you flip it, okay? So if our original slope was negative 3 over 4, our perpendicular slope now is going to be a positive 4 over 3. So flip it. And we want to pass through the point negative 4, 5. So our equation is going to be y equals 4 over 3 times x plus 4, because we have a negative 4 right there, plus 4 plus 5. Okay, I'll go ahead and graph this last one for you so you can see. We're going to graph both equations. So the first one was negative 3/4 is x plus 2. So I'm going to start at 2. I'm going to go down 3 over 4. So 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Go the other way. 1, 2, 3, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. Okay. So I'm graphing that first line in red, and then I'm going to do this, the perpendicular line, I'll do it in blue. Okay, so we have the point that we're passing through is negative 4, 5. So that's where I'm going to start. I'm going to put my first point at negative 4, 5. So 1, 2, 3, 4, up 5. Okay, and we have a slope of 4 over 3. So we're going to go up 4 to the right 3. So 1, 2, 3, 4 over 1, 2, 3, 4 over 3. And then I'm going to go the opposite way. 1, 2, 3, 4 over 1, 2, 3. And I can do one more time. 1, 2, 3 over 3. So these lines are perpendicular. They have that perfect cross. Okay. And so this is the line that I graphed in blue, and the original line is the one I graphed in red. So please make sure that you graph both lines, and that is going to be the end. So I will check your graph here, your graph here. I want to see you do that graph, that whole problem there for lesson trick number 2. And I want to see you finish this one right here, this checkpoint as well.